In this problem, we're asked to solve for x in this expression, which equals 0, 0, 1, 0. So I'm going to start, there we go. I'm going to start by doing the LCirc2 of x, which we are going to replace with a, b, c, d, e to stand for x so that we can solve for the individual bits. So we're going to do the LCirc, we're moving to the left. The a goes to this side and the b goes to this side. So now we can also do, okay, that was this. Now we can do this one as well. So our circ2 of x again is a, b, c, d, e. It's the same x. This time we're going to be moving to the right. The e goes to this side and the d goes there. Okay, so now I'm going to rewrite the expression. We have 1, 0, 1, 1, 0, and C, D, E, A, B, or D, E, A, B, C equals 0, 0, 0, 1, 0. Okay, so now we can do this parentheses, and we can compare each of the digits individually. So we have 1 and c is going to be c. If c is 0, it's 0. If c is 1, it's 1. Then we have 0 and d is going to be 0. 1 and e is going to be e. 1 and a is going to be a. And 0 and b is going to be 0. Now if I rewrite this, it's C0, E, A, 0, or D, E, A, B, C equals 0, 0, 0, 1, 0. Okay, so now we're going to compare the digits individually again. And the only things we know for certain right now are that this digit is 0 and this digit is 0. So we can use those to start. So 0 or E equals 0. So we know E has to be 0. And then this 0 or C equals 0. So C has to be 0 as well. Now we can plug that in. So C is 0 and E is 0. So C or D equals 0. D is 0. E or A equals 0. So A has to be 0 as well. Now we can plug that in for A. We have A or B equals 1. So finally B has to be 1. Then if we put this in order, we have 0, 1, 0, 0, 0. And that is your final answer for x.